Hello, sir. This is GVS Nagafani, and my registration number is 20ML0312. And today I'm here for my digital assignment one design patterns. And in this video, I'm going to discuss about the introduction of design patterns. As we all know that patterns are something that represents itself under the context. What is the context mean? Context is a scenario where the problem will be arising. As you can see here, this is the process and this is the input, and after inputting will get the output. But here will be the process will be constant. It won't be changed, but inputs will be different, and based on the inputs, different types of inputs, different types of outputs will be generated. And context is a situation where the input the problem will get arise, and here the inputs will be changed continuously, and for every input, for different inputs we should get the correct output. So it is not possible every time, because for some of the inputs will get the output, but for some of the inputs will not get the correct output or expected output. This could be because of the many errors or some bugs and all. So in order to make changes, uh, we should ensure that coupling is less in between the modules, because as we all know that coupling is nothing but the force that exists between the modules within the project. So the higher the coupling rate, there will be less chance to make changes, or there will be more. Like if the coupling is very low, there is no chance for making changes in the project. So it won't be flexible. More coupling, less flexible. So the experts or the people applied some of the templates, or they follow some procedures in order to solve this problem, or they applied some procedures in order to develop a project. So those procedures are documented, and they become a solution for the upcoming generations or upcoming uh, employees. So those becomes the patterns. So that's how we got the patterns. So patterns are the well-proven documented solution for the recurring problems. And coming to the patterns, these patterns are divided into three types, where architectural patterns, design patterns, and idioms. So example of the architectural patterns are MVC model, which abbreviates model view controller, and example pattern of design pattern is observer pattern, and counted body is the example for idioms. Here, coming to the architectural patterns, it can be applied in a broader scale, but the design patterns will be applied in lower or medium scale projects. And idiom patterns are applied when the problem is language specific. Like we'll see about all these types of patterns in detail in the next slide. So coming to the model view controller pattern, we have three main components in it: model, view, and controller. But before going to the model view controller, let me explain you the difference between the architectural pattern, design pattern, and idiom. Here, architectural pattern is nothing but like a designing a building. So we are designing the outline of the building, and just we are designing only the external part of the building, right? So that describes about the architectural pattern. And design pattern is nothing but the interior part of the building, like how many rooms should contain, and which floor, how many rooms should contain, and what is the relationship between the rooms. So like that, if the room could be termed as a module, like what are all the modules well should have to be present, and what is the relationship between the modules, and how the module should be designed, and what is the functionality of that module, that and all will be discussed in the design patterns. And coming to the idioms, it is language specific. We will see about the idioms in the later few slides. And now in the model view controller, here the view. is termed as the output module, and controller is termed as the input module, and model is the where all the content like will be having all the code part and the functions, classes, everything will be in the model part of the model with controller component and controller. Coming to the controller component here, this where the user will give input and controller will take the input from the user and it goes to the model. And now model will make changes in the view as the user will be interacting based on the view component, but he is indirectly interacting with the controller actually. So the model will make changes in the view part, and the changes will be reflected in view after looking those changes. And if the user wants to make further changes, and he will be interacting again with the controller, and model will be changing. It will be like a cycle. Uh, so that's how the model view controller works. And when it comes to the technical part, we should design the model view controller in such a way that the model should uh, uh, attach or detach n number of views and controllers, and the views and controllers should be designed in a way such that they should be attached or detached with the model whenever they want. Coming to the next thing, observer pattern. The observer pattern is under the design pattern, is an example of design pattern. And here the observer pattern you can see this comes after the model view controller because as we all know, in model view controller, if the model undergoes any change, according to that, the view and controller should be changed. This is the uh, publisher and subscriber model or publisher and subscriber point of view. So here the publisher will be the model and subscribers are these two who will depend on the model. So the problem is that the model will be changed whenever it wants. Whenever it wants, the model will be changed. But the problem is to be updated by the model in view. It is difficult because every time the model gets updated, these viewer controllers will not know whenever this model will get updated. So something should be there to inform them uh, that the model has been updated. So according to that, U2S also should be updated. So that problem will be solved by observer component. Observe here we have indicated through observer box. So here it contains the function also update function. So it will intimate both the model and view components to be get updated whenever the controller component will be updated. So this will be done in two types. One is the pull type and push type. So the uh, pull type refers to where it is used by the view and controller. So the view and controller will continuously sending the signals to the observer, and observer will continuously send signals to the controller, or the observer will continuously check whenever the signal will get from model and view. So if there is any change, then the model and view will be updated accordingly. Or else we have the push method. Using the push method, the controller will whenever the controller will get updated, the observer will inform those model and view components. So that is about the observer pattern. The observer pattern is the next stage or next step to the model view controller model. So coming to the third thing, idioms pattern. So idioms pattern, a good example for the idioms pattern is counted body example. So, as we all know, if there is any project that is going to be completed, 95% of the project will be completed if we apply these architectural pattern and as well as the design pattern. But 5% of the project may not be completed because of the language specific issue. So the project working will also be dependent on the language that we are about to choose. If it is a dynamic type language project, so it is very easy for the developers, and if it is static, it is somewhat difficult to accomplish the project. So the developers will face the issues at this stage. So these language specific issues will be solved by the idioms. And also, before going into that, let us understand the difference between abstract class and the concrete classes. Abstract class is where we don't have any definition inside the class. We just have the method name. Only method name will be present, and the implementation part or code inside the method will be present outside or in its child class especially. And concrete class is where we have the implementation or we have the definition. And also, let us understand the what is an interface. Interface is something, it's just a signature, like it's a group of signatures combined to form an interface. And these interfaces are different from the implementation. There will be only one implementation, and there can be many interfaces. As in the idioms design pattern, we term these interfaces as handles. We can have multiple handles for a single implementation. And you can see difference between the interfaces and implementation. Interfaces is nothing like but the we just have a handle or we just have a function, and implementation is where this handle will get attached to the implementation, and it will get the data from there. So there will be many classes, and one single class can create a single or multiple handles, and these handles are combined to form an interface, and they are all dependent only on one component, which is an implementation. And also coming to the next topic, call by value and call by reference. So let us assume that we have a data here, and if a class E comes, and if it want to access the data, and it is a universal data, like which means that the data should have to be accessed by class A, class B, class C, or class M till n classes. So if the class A wants to make use of it, it can't use directly because uh, it the universal data will have a authorized access, right? Authorized access. So using the call by value method, we'll get the copy of that data. But there are certain problems with the call by value also, and call by reference is nothing but the data will be referenced using the pointer. So using the pointer, we'll be getting the data, and whenever the use of the pointer or whenever we are satisfied with the data, we have to close that pointer, right? That's what the call by reference method resembles. And there are certain problems with the call by value method and call by reference method. The problem with the call by value is we are copying the data into another variable. That we are creating another variable, and we are copying the universal data into our local variable, and that class, or it could be class A or class B or class C, has access to that variable class. Variable A has an the class A has access to variable A, like that. But the problem is that we have to create n number of variables for n number of classes, which is very tedious because we have to create n number of variables. Right? The storage will become expensive because we should have more storage, and it will be very expensive. So we'll move to the method called call by reference method. In the call by reference method, the problem is that we are using pointers to access the data, right? So if a class A makes any changes, and after that class B comes to that universal data, uh, it will see the updated value by the class A, but not the original value. This is the problem. And also, if the pointer accomplishes its task, the pointer will be kept at that functioning point only. So it has to be removed, right? Because the memory is very valuable in a project or in a device. Memories should be managed effectively. So in order to do that, we are using the garbage collection. The garbage collection should be done effectively. And also another thing is that visible disruption between the user-defined and built-in data types. As we all know that in the object-oriented programming language, our main motive will be on creating the built user-defined data types. So as with the language, we get some data types which are built in, but according to the user, like on their purposes, we are creating the classes, and the classes will be accessed through objects. So everything we are doing with the classes and objects, it is termed as user defined. So object oriented programming should be in such a way there should be no difference between the user defined data types and built-in data types. The user should not feel difference between the user defined data types and built-in data types, and that's how we term how good is the object-oriented programming in particular language. And the solution for the above problems is first thing is counter variable. This counter variable helps in solving the problem of garbage collection. Here, as we all said, if the pointer completes its task, it should be treated as wastage and it should be eliminated from the device in order to effective managing of the storage. So the counter variable will get incremented if the class A wants to use the data. The count will increase to 1, count plus plus, count equal to 1. When class B comes, count equal to 2. When class C comes, count equal to 3. Like that. So like the counter will be increased, right? And if the class withdraws its access, because if the work completes, the class withdraws its access, so the count will be decremented. Whenever the count becomes 0, the data will not be accessible to anyone because no one is using the data, so the data will not be active now. This is how the memory management module also works, where if class A wants to modify the data within the data that is accessible to everyone, immediately will shut the access to every that class and will make the data to be copied by that class. So, if the class B wants to make some changes, we are giving access as read access to every class. If class B wants to write, then we'll give the copy of the data and we'll shut the access to that class. So that the original data will be retained there itself, and there will be no problem for the remaining classes as well. So this is how the idioms topic uh, gets completed, and now we'll see a few topics like integration of patterns. If there is any project that and we have certain problems in the project, so to solve the problem, there is no such single pattern is available to solve one single problem. So we should use 2 to 3 patterns in order to solve the problem. So for that, integration of patterns is very important. Example is the MVC and observer pattern. As you can see, the observer pattern is an updation of model view controller. So the observer pattern and model view controller pattern are being integrated here. And also the next topic is variant of a pattern. Uh, Here the scenario will be the word processor. If there is any word application that I am using, and if I am typing a word here, a key. If I am hitting a key here, it goes to the controller and automatically the view gets updated, right? So here, the thing is that the controller is also controlling the output also. The controller work is to control only input. It has only access to input. but it is also updating the view component also immediately, and it is also taking control upon the both output and input. So to solve this problem, we are combining the both view and the controller component, and we are making the pattern as document view pattern. This is the new pattern and it is the updated version of MVC pattern where the view and controller components are together. This is called a variant of pattern. So document view pattern is a variant of MVC pattern. And next, coming to the next topic, three problem sources. There are three problems when we are doing a project. Like so, whenever the client is sending a message, that message or the client should not bother uh, in search of that server. To they are sending a message to the server, right? So they should not bother about the location of that server. Is the first problem. And second problem is that inter-process communication. So the client should not bother about which inter-process communication method we are using. And the third point is the client should not be aware of the location of the server, what is the name of the server, what is the type of the server, and all. He should not bother about. These are the three major problem sources. And in order to tackle these problems, we are using the proxy pattern and forward receiver pattern. So the what these patterns will do is that it will receive the message, and it is like a virtual private network, as we all know the VPNs and all. So the intermediate server receives the message and that will be communicated to the original server, so that the user will not know what is the original server, because he is only communicating with the intermediate server, right? And intermediate server is communicating to original server. He doesn't, the user will not know what is the address of the original server, and what is the type, what is the name, what is the address of that original server and all. So this is how we are solving using the proxy pattern and forward and receiver pattern. And one last topic we are remaining with, that is the uh, naming conventions. So if we are creating any object, then we should use a noun, and that object should be a physical counterpart, something that has something that is in the physical form. We are treating it an object and we are giving it a noun name. And if it is something like a verb, example, calculate, if there is any function, calculate, or then compute, like that, these are all the verb actions. So these are all termed as the functions. Like for the functions we should use the verb names and all. And also in the noun part, for 95% of the noun names will be given to the objects, such as in VTOP, if you see admin, parent, student, faculty, like that, these are all the objects, and these are given, the object will be given a noun name for 95% of the cases. For the 5% of the cases are exceptional, like arrays and linked list and all. Those are all exceptional cases. So that's it about the introduction of the design patterns. And thank you, sir.